3.6, chain rule. If you're not happy with your test grades, it's because we're not getting through all the practice problems I want to in class. Because you guys won't stop talking, and you keep being distracted. I give you all of the 3.3, 3.4, the whole, review. Yeah, that was supposed to be done during class. Why aren't your test grades as good as they're going to be? Because we're not getting through the stuff we're supposed to. So, let's focus. Think about your grade, because I have no qualms. I love you as a person, but if you get a C, you get a C. Right? So I am trying to give you as many examples as possible. You got to work with me, okay? Because I can't just give you a random grade. It's the grade that you are earning. And, we're great as humans, but right now, you guys are not being A-level students. You keep being distracted. Get off the table. Come on, what is this? All right, chain rule. So, how do we know? Now we know how to differentiate sine of x. What is the derivative of sine? Cosine, right? So this is literally one function. I'll call it f of x. And we know the derivative of x squared minus 4. What's the derivative? 2x. Okay, so I'm going to call this a different function. I'll call it g of x. So we know how to do a single function. But what about if we have a composite? So this is exactly what you were talking about before, right? Fog and Goff. So what if I have a function inside a function, right? It's going to be a composite. So what if I have f of g of x? How do we actually differentiate this? So it's called the chain rule. Have you guys ever made those paper chains? They're all connected. Yeah. Oh, exactly. It's in the Sukkot. So this is the most widely used differentiation rule in math because rarely do we actually have one function. Normally, the functions that we use are going to have it'll be a trig function, and then inside the trig function is another function. It's very, very common. Honestly, sine and cosine are normally your outside, and then you always have this random stuff inside, and sometimes you have tangent on the outside. When you're looking at stars, literally, the light that comes down, right? So these pictures, it's kind of like you have a bunch of buckets. It's a matrix of buckets. And each bucket has a certain amount of photons, certain amount of light. So you can actually, you can model this pattern of light that's on your picture using a sine wave with a function inside of it. There's these really cool things called Fourier transforms. No. Okay. I realize you probably never heard of it. It's fine. Just the most important thing is, guess what? This is really important, so you must know how to do it. If this is hard, you have to get to a point where this is just easy and second nature. Okay, so how do you actually do the chain rule? If f is differentiable at a point u, literally, if it's differentiable, you can take a derivative there. And g is differentiable at that, and at the point x, and the composite function, fog, is differentiable at x. Okay, so what do you notice? So I have the derivative of fog is literally going to be the derivative of my outside function with the same function inside times the derivative of the inside. So it's a chain. It's kind of like those Russian dolls, right? You do the outside one, you take the derivative of the outside one, and you keep the inside. Take off the outside, then you look at the inside doll, and you take derivative of that. So it's possible to have 50, a function that's in a function that's in a function. So literally you're pulling through the chain because they're all connected. That's why it's called the chain rule. So you take the derivative of the very outside function. So here it'd be sine. And you keep whatever's inside. So derivative of sine, so it would be, do I have that up here? Okay. So if I would want to take the derivative of sine of x squared minus 4, I start by doing the derivative of the outside. What's the derivative of sine? Cosine. So it's cosine times whatever. I keep the inside. And then I multiply by the derivative of what's inside. So what's the derivative of x squared minus 4? 2x. So the derivative would be 2x times cosine of x squared minus 4. So it's the derivative of the outside times derivative of the inside. So keep in mind the derivative of the outside, all I mean is
why are you still keeping the x squared minus 4?
You have to, so I have to keep what's inside first. So you're working your way in. So the first, how do I explain this?
What's the difference between this go from sine times x squared minus 4
So Wait, I'm sorry, repeat your question?
Like, what's the difference if you just go from, why can't you just go not cosine?
Well, how did you know it was cosine times 2x? Because you're taking derivative of the outside times derivative of the inside. That's all the chain rule is. Like, it makes sense, right?
Yeah, like, you know the derivative of the inside is 2x. So
Yeah.
I don't get why we
So it's not cosine of x times 2x. That's not what it is. It's not cosine x 2x. It's cosine of whatever. Cosine of whatever. Cosine, same stuff inside, times derivative of what's inside. So, okay. So her question is, just a moment. Raise your hand if you have a question. Hold on. Okay. So I want to make sure we all understand this. So what I'm doing, so f of g of x. I just want to make it clear. F is the outside. G of x is the inside. Right? So what I'm going to be doing, so dy dx is going to be equal to the derivative of the outside one. So when I say derivative of the outside, I'm dealing with this function. I'm not changing what's inside. I'm taking derivative of the outside function, leaving what it is inside. Then I'm going to the next link in the chain. I'm going inside, take derivative of the one that's inside. And imagine if you have three, like a function and a function and a function. I think I'll get to an example like that.
Yeah, but that's why I don't get why if you already took out the 2x, why do you still have the x minus 4?
So,
Well, you just cross that.
okay. So what is the derivative of sine of u? Cosine of u, right? So I'm not changing what I'm taking sine of. I'm not changing what I'm taking cosine of. I'm not changing the angle. What I'm doing is changing what trig function, because that's the derivative. So since my angle here was x squared minus 4, the derivative would be cosine of x squared minus 4. But the issue is I have a function inside a function. Yeah. I think a couple more examples would help. It would be, so my final answer is 2x times cosine of x squared minus 4. That's the derivative. Alright, so use the substitution and chain rule to find dy dx. Question, okay, Noah?
First one where it's like on and off,
Mm-hmm.
but then it says Lebanese coefficient. Like a different way of getting
Leibniz.
Lebanese.
It's fine.
What?
So this means the same thing. It means the same thing. So here dy du, because it's saying u is gx.
So you get the same thing.
Yeah, it's the same thing. It's the same thing. So actually, so when calculus was invented, there's actually two different people that invented calculus separate. What? I know, because I can't see. I'm really blind.
I know, I've never seen it either. I was going to say it.
Can I see it again?
No. Do you remember that 5 minute rant I went on about like distractions?
Yeah.
Check. Okay. So, what the heck is Lebanese? Leibniz. There's two people who independently invented calculus. Depending who you talk to. Because that's his last name. Why is your last name Anish?
I'm saying one of the guys was Lebanese.
It's not. He's German. It's...
What is life and what is
Newton and Leibniz independently invented calculus. Hi. Okay, well, I'm done. You can read about that yourself. So I'm going to go over this example. So that means the same thing, though. So Leibniz notation is with the dy dx. Newtonian, right? Newton, he came up with the prime, the little tick marks. So depending on, let me go with Leibniz notation versus Newton. It's the same thing. It's showing you two different ways to write it. Okay, so here we go. Use the given substitution in the chain rule to find dy dx. So here, y equals cosine of x squared minus 1, and then u equals x squared minus 1. So the idea is you're taking, so up above it says dy dx, literally the derivative with respect to x, is going to equal dy du times du dx. So what the heck does this mean? Okay, we already said u equals x squared minus 1. So if I rewrite the equation, I have y equals cosine of u. So what is the derivative? What is the derivative of y with respect to u? Equals negative sine of u. Okay, and then we know that u is equal to x squared minus 1. So what is the derivative of u with respect to x? Du dx equals 2x. So this is breaking it down. This is a form of like u substitution. Because it's a lot easier to understand like, oh, clearly, derivative of y equals cosine u is just negative sine of u. But wait, what is u actually? Oh, it's another function. It's a composite function. I have x squared minus 1 inside here. I think it's a little easier to see the fact that like u here did not change. It's the same function. Okay. Okay, so question, if I have dy over du times du over dx, what happens with du? It cancels out, and that's why it's equal to dy dx. Okay. So if I take this and multiply by here, I have my answer. I take negative sine of u times 2x, but wait, I should probably plug x squared minus 1 back in for u. So dy dx, so I have to take dy du, which is negative sine of u. But instead of saying u, I'm going to plug in what u is actually, x squared minus 1. And then I'm multiplying by du dx, which is just 2x. So the way I write this, so that way like it doesn't get lost, I always put the coefficient 2x like in front, like here. I always have the trig function at the end. So I'd write it as negative 2x sine of x squared minus 1. So the reason I do this is because it's very easy to accidentally put like a plus or minus here, and subtracting it is a much different thing than multiplying by it. Okay, so try another one. Yay. Does everyone have a notes packet? Yes, you two don't have these. Do we want to go through this whole thing tomorrow? This all will happen if you're focused. Yes.
If there's really see much to do, it's so nice.
The first way to do it. So I'm showing you two ways to do it.
Okay, so it doesn't matter.
So up here, the way I literally wrote, like all I did was I wrote, negative sine x squared minus 1, and then times the derivative inside 2x. Yeah, that's a faster way. I mean, some people didn't see it, so I'm showing that way. This is being a little extra, but it's fine, because this is the first time you probably saw it. Alright, B, y equals sine of square root of x. So u equals root x. So this makes it a little easier to see. So sine is the outer, root x is the inner. So y prime is going to equal the derivative of the outer times derivative of the inner. Well, both of these are chain rule. I'm just showing you two different ways to.
The other one, right?
What do you mean? Oh, the other notation. Yeah, other notation. What? This one? Okay. So what is the derivative of sine? Cosine. So it's cosine, and wait, what's my angle? Oh, I literally leave what I'm taking sine and cosine of. It's the same thing. I'm not changing the angle. Here my angle is root x. I'm not changing the angle. The derivative of sine of x is just cosine x. The derivative of sine root x is just cosine root x, but it's a composite function. Root x is a function that's inside sine x. Sine. So then I have to multiply by the derivative of the inner. So this is a little, what? Y? 1? No. This is root x. This is not sine x. So technically, this whole time that we've been doing sine x, we've been like multiplying by the derivative of x, which is just 1. That's why we haven't like dealt with this yet. But if it's not just x, it's root x. All right, so think about root x is the same thing as x to the 1/2. And so if we want, should I do a different color? No, let's do this. So if I want the derivative d dx of x to the 1/2, power rule. So you take the exponent, bring it down, and subtract 1 from the exponent. Yeah. 1/2 x to the negative 1/2. You know what this looks like? Simplify it a little more. 1 over 2 root x. I mean, I'm going to put it as 1 over 2 root x. That way when I come over here, 1 over 2 root x. Oh my god. No, come on. 2 root x. I can write this, I can simplify this as cosine of root x all over 2 root x. No. The 1/2? You're talking about like, is this, no. I would do this if it was. So if you have, okay, so I guess an intermediate step here would be like 1/2 times. Another way to say x to the negative 1/2 is 1 over x to the 1/2, which is just the root. All right, cool. All right, do we have enough time to write down? Yeah, definitely ask questions. How many pages is this one? Okay. So, an object is moving along the x-axis, so its position at any time t is greater than 0 is given by x of t equals cosine t squared plus 1. Composite function. We must use chain rule. Find the velocity of the object as a function of t. So, if I have a position equation, how do I find velocity? Derivative. What's the name of the chapter? Derivative. Okay. Wow. So take the derivative of this. It's the same thing. I have position. I need velocity. So I must take the derivative. So right now I have x of t is equal to cosine of t squared plus 1. Okay, just to be clear, cosine is my outer, t squared plus 1 is my inner. That's exactly what we're doing. I'm just going to explain it again, because it's a lot to listen to, but it's excellent. So, we have position, we need velocity. Right, so how do you find velocity? You take the derivative. So that's what v of t equals x prime of t. All that says is, the first derivative of x of t. So notice that my position equation is a composite. Literally, a function is in a function. So I have to use chain rule. So first, I'm going to take derivative of the outer. Derivative of cosine is negative sine. And then I'm leaving what's inside, t squared plus 1. Then I have to take derivative of the inner, which is just, 2 times t. And because it's very easy for you guys to, maybe your multiplication symbol was a little, more drawn out, might look like a minus sign, just so there's no issue in communication when I'm, looking at your stuff. And because I am mildly OCD when I'm doing problems, the way I do it doesn't leave anything confusing. All right, so I move the 2t in front because it's a coefficient I'm multiplying. If I take 1 times 2, it's the same as 2 times 1. That's why I can just write it in front. So negative 2t times sine of t squared plus 1. Yep, that's it. Cool. All right, so 1 page done. So, outside, inside rule. So, outside, inside rule. Differentiate the outside function f and evaluate it at the inside function g of x left alone. Then multiply it by the derivative of the inside function. It's the same thing. Yeah. It's literally the same thing. This is literally the same thing.
What's the difference between the chain rule and the outside inside rule?
Yep. Yep.
Wait, it's not any different?
Doesn't look like it to me. Nope. Yep.
Just add an extra word.
Well, instead of saying outer and inner, well, I mean, I kind of already been saying it. It's, notice, wait, ready? Look at what I'm highlighting, ready? Look at this. How does that compare to this? Oh, surprise. But notice this top one was, fog, whatever, this is the same thing. Okay. It is. Okay. How do you find it? Oh, literally, I have a composite function. Take the outside derivative, comes the inside. Okay. So the part that you might mess up is maybe you forget to write the 3x. So y prime is negative sine of 3x. And what's the derivative of 3x? 3. So to write this, y prime is equal to negative 3 sine of 3x. You need to move this to the front. All right, you have to move to the front whenever you have this. Let's not be ambiguous. If you don't do it, I'm gonna take little points off. Just do it. Do it. Do it. Okay. I told you 5 times to do it. How about we do the next problem? I think that's your question, right? Do you see what's gonna happen? Yeah. All right. Sorry. Do we have time to write this down? We did it. Okay. Yeah. All right. Try the next one. Sure. Let's do it.
Okay,
yeah.
So it's first you take the derivative of sine, which is cosine, and then you multiply it by the derivative of the inside, which is 2x plus 1.
Wonderful. So you could just write this as 2x plus 1 multiplied by cosine of x squared plus x. Yep. I mean, does distributing it really help? Nah. Yeah, that's it. Okay, cool. The next part is what I talked about before. So right now we've had 2 links in our chain. Because literally we've had 2 links in our chain. I've had one function inside of one function. What if I have a function inside a function that's inside a function? They're all linked together. It's the chain rule. They're all literally linked together. That's why you're multiplying them all together. It's chain. Okay. Yeah. Okay, repeated use of chain rule. Sometimes we have to use the chain rule 2 or more times to find a derivative. So, let's do this. Find dx of tan of 5 minus sine of 2t. So, the first thing I'm going to do, so maybe I should color code. So this is like out. Here's the, hold on. This is like the middle. Oops, if I spell correctly. And then guess what? This guy right here is like the inner. So you work your way from the outside in. So you take derivative of the outest one. And then you take the one that's next. And then you do the next. And then you do the next. It's the Russian babushka dolls. You just work your way in to the smallest one. Did you say babushka? No, do you, sorry, in your life, do you say babushka?
Yeah.
Okay.
It's more fun.
Thank you. That's what my grandma, yeah, I can still call my grandma.
There's
Yeah.
a word name for it, and there's not that.
Because, yeah,
Oh, the Russian nesting dolls.
Russian nesting dolls, aka babushkas.
That's fun to say.
I know. That's the boring American say.
Okay. Okay, let's do this. What is the derivative of tangent? Secant squared.
Oh, I
Secant squared x. Okay.
No way.
That's crazy.
So secant squared of everything that's inside. Okay, next I must do the middle. What is derivative of 5 minus sine of 2t?
Cosine of 2.
Cosine 2t.
Negative cosine.
So derivative of sine is cosine, but I have a negative in front, so it's going to be
But
negative
cosine.
cosine of 2t. And then I have to multiply by the very inner one. What's the derivative of 2t? 2. So I'm color coding. If you can't tell the difference between my colors, let me know. 'Cause I'm trying to like keep it showing how we are going in. Uh-huh. Yeah. Derivative. Okay, so I see there's a question. Let's take the middle one, because the derivative of 2t you got. Derivative of tangent is just secant squared. But our question was 5 minus sine of 2t. Derivative of 5, 0. Derivative of sine is cosine 2t, right? And then of course you'd have to multiply by the, inner, but we're not dealing with that. But since there's a negative, derivative of sine is positive cosine, so I have to keep the negative in front. If this was a negative cosine of t, derivative of cosine is negative sine. So the negative comes down and then it would cancel. Yeah. That's why I have a negative here, is because I had a negative to begin with. Derivative of sine is just positive cosine, so the negative comes down. So let's see, we derived it together in class. We did the quotient rule. So if you don't remember, just do the quotient rule. Tangent is sine over cosine. Was it? I thought it was. I don't know. I don't remember. Well, we can do it right now. It'll take 5 seconds. Just kidding. It'll take like a minute. So this is gonna be negative 2. I'm gonna leave this. Hold on. Negative 2 cosine 2t times secant squared, the negatives from right here. Secant squared of 5 minus sine 2t. So that is the whole thing. Oops. So I'm doing quotient rule right now to prove it to you. Low d high, take high d low, cross the line, square the low. So, ugh. Hold on. Oh, wait, this is not negative. Okay, so if I simplify this out, I'll have cosine squared x. Let's see, negative sine x times negative sine x is plus sine squared x all over cosine squared x. So this is tangent. This is the derivative. So I'm just showing. Yeah, this is like, if you don't remember, here we go. Because it's not too bad. What is cosine x plus sine x? 1. Pythagorean theorem. This whole thing is just 1. And then, so if I have 1 over cosine squared x, that's just secant squared x. Yeah. So you have to know derivative of sine and cosine. The other 4 functions, I mean, you can just do quotient rule and figure it out. Cool. Woo, woo. Okay. Power chain rule. Power chain rule. So I think we can get through some of these. Yeah, because I have 2 days planned for 3.6. So I'd like to get through at least 2 of these examples. That way we have time next class to go through some worksheets. Okay, power chain rule. Chain. Yeah. My nephew keeps, well, my sister calls me and he just keeps talking about trains. When you're like almost 3, that's all you care about. D dx of u to the n. D dx of u to the n. So, literally, this is if you have a function to some power. Because, okay, if you have a function to some power, so here is a function we know how to take derivative of 1 plus cosine of 2x. But then wait, if you're squaring it, we know the derivative of, oh my god. No, okay. We know the derivative of x squared is just going to be 2 times x, right? Because we subtract 1 from the exponent. 2 minus 1 is 1. What if I have a whole function that's squared? So it's literally the power rule. So we have to combine power rule and chain rule. So first, you would bring down the exponent, and then you leave the whatever's inside, and then you work on the inside, and like, okay, now what's the derivative of that function? Okay. Sometimes I'm not as clear as I would like to be when I'm describing
Is it basically
things.
like the inner and outer, but
Yep.
you just
But the outer is literally, you're using
Same
power
thing.
rule to bring it down. Yeah. Okay, so I'm going to rewrite this in terms of a power. Y equals tangent of 5x to the 1/2 power. So if I want the derivative, we start with the outer, which is with the exponent. So you bring down 1/2, and then you have to subtract 1 from the exponent. So 1/2 minus 1 is negative 1/2. Okay, cool. So now we have to work our way in. We have to work our way in. So now, what is the derivative of tangent of 5x? So this is going to be secant squared of 5x. Oh, this was a devil problem. I literally have a function, 5x, inside of tan. And then all of that's in a power, so we have to go one step further. Aha, what's the derivative of 5x?
5.
Yeah.
That ain't too bad.
Because this is a function itself.
we're just like taking as many
Yep, we're just going all the way in.
But I thought that the 5x is just like part of the tangent. Like they just look at that.
No.
What?
So up here, maybe I should have, okay. Where did I do it? So we found the derivative of tangent. So technically I could use the chain rule on tangent of x. Derivative of tangent is secant squared x, and then what's the derivative of x? 1. So technically I've been doing this the whole time, but I've only had an x inside, so it's just been multiplied by 1 the whole time. That's why I didn't like describe it to you before. We gotta do one step at a time. Okay. So down here, first we had to deal with the exponent, right? Everything was in a root. Then I had to deal with my trig function. Then I had to deal with the angle that was a function. So 5x is a function, that was my angle. Then my trig function, and all of that was in a square root. So there's like 3 different things I had to do. So if I'm going to simplify this, or not simplify, but rewrite it. So this is going to be 5 secant squared of 5x all over 2 root of tangent of 5x.
I'm such a messy person, so I don't get this one.
So as we go through class, I'm trying to model like what your paper should look like. Clean, easy to follow, nice logical steps. If you need more room, more paper, I will gladly give you the whole ream of paper that's in the office room if you need it. Because I want to be able to follow your train of thought. I spend too long grading papers, and I'm just, if I can't follow it, I can't give you the points, all right? So think about it that way. Like, I have to see what you're doing because there's points associated with every part. You don't have to color code it, but I need to see there's a clear, logical way, like there's a path through. It shouldn't just be haphazard. Just go line by line. I will give you paper if you need it. Okay. Let's try the next one. Sorry, did we have questions?
Yeah. Why is it a 2 on the bottom?
1/2 is 1/2, so 2's on bottom. 1/2 is the same thing as 1/2.
It wouldn't just be a half.
Yeah, but that's what, wouldn't it just be root? Why is it
No.
two?
Because I have this 1/2, because I move, so the exponent comes out front, so 1/2, so I'm multiplying by a half. So I literally have 1/2 times 1/tan 5x to the 1/2. Yeah. And so you see, oh, it's literally going to be 2 times.
So if you didn't have the 1/2, you just need to
Yeah. Because the 1/2 comes from the power rule. Perfect. Let's try B. So, okay, I am going to have the outermost is the power rule, then deal with the cosine, the trig function, then inside is the 2x. So there's 3 different things I'm going to have to deal with. If it was just cosine x inside, then we're fine, right? Because we'd only have to do 2 derivatives, but this time we have to like work our way all the way inside as long as we deal with everything. So first, I have this like power to deal with. This is the outermost. Then I have this middle function. And then inside that is this like 2x. So you see how we're working our way in? Yeah, colors. Okay, let's do this. So y prime, derivative of, okay, so I have the 2, I bring it down, and then I multiply, I just take 1 away from the exponent, so subtract 1, 2 minus 1 is just 1. So I don't need to write 1 as an exponent, it's just implied if I don't write it. Now I need to deal with the middle. So without saying anything, think, what is the derivative of 1 plus cosine of 2x? Exactly. So derivative of 1 is just 0. I ignore it. Derivative of cosine is negative sine. And then I have my same, I have my same angle. And then the very most inner times 2. So if I want to rewrite this, I have y prime is equal to negative 4 sine of 2x. Because I have, yeah, right there, times 1 plus cosine of 2x. I think it's just going to take practice. That's why we got a whole worksheet to do. All right, cool. I think we can... Okay, let's do the first 2 problems of the chain rule worksheet. That will take probably a shorter time than the next example.
Oh my god.
I'm going to print these. I'm going to give you guys like a minute to try out number 1 and 2 of the worksheet.
Wait, what?
The worksheet I gave you, it's called the chain rule worksheet. I want you to do number 1 and 2. I'm printing the new updated dates for you. I want you to try 1 and 2. What's the derivative of 4t plus 9? 4. And then derivative of blah with you bring the 1/2 down, subtract 1 to the exponent. I'll be right back.
I understand that, but it's just like, I remember doing it. What? Everything is just described.
So y prime, This is just for, oh, it's literally all over. Oh, times 4. So it's just going to be 2 over 4t plus 9.
Isn't it not?
One negative, so negative 1/2, bring it to the bottom, so it'd be that to the 1/2, which is radical. Guess what 4 over 2 is? 2, that's why I have 2 on top. Try out number 3, I'll be right back.
Oh.
No. There's only Fridays is the I will never know unless you're gonna have everything else. I'm just not doing it.
That's not a problem.
Well, cosine of theta over 2 is cosine of 90 degrees.
Oh.
Which is pi over 2. It's 0. Because it's at
Yeah,
90
what's theta
degrees.
over 2?
And x at 90 degrees is 0.
So it's 0.
So it's 0. So it's just cosine of 0. Or no, cosine of that is 0.
No, I think the answer is just 0.
Yeah, because
Because you multiply by 0
by 0 and it's 0.
So it's 0.
Oh, so 0.
Theta over 2 is 0.
Number 3 is 0. Or is it 1? Because sine of 0. Oh my god, that was me.
Alright, so right here.
Notice, these are the most up-to-date, dates.
Does anyone know what period is?
G.
Ah.
Thanks for the real G.
So your test, like everything is shifted by 2 days. And just so you know what's after this, we learned 4.1, we learned 4.2, we have a quiz, 3 days review for the final and the final. Like that's the rest of the semester.
Oh my god.
Let's go.
Cool. All right. I'll see you guys Tuesday. Woo.